Hey guys, today we're going to talk about something called perfect square trinomials. Now in order to do this, we're going to start off with factoring a trinomial that we're used to factoring, and then we're going to examine it a little bit. So we'll do x squared plus 8x plus 16. So if we were to factor this, we would be looking for two factors of 16 that add up to 8. And if you go through and list, 16 times 1 doesn't work, 8 times 2 doesn't work, but 4 times 4 would work. So we would end up with 4 and 4. And since we have all positives here, we would have a plus and a plus. And if we go one step further, if you have anything, like let's say you have a times a, you can represent that as a squared. So we have x plus 4 times x plus 4. We can represent that as x plus 4 squared. So to factor this, we would actually go from x squared plus 8x plus 16 is x plus 4 squared. This right here, this trinomial, this is a perfect square trinomial. And we're going to see if we can figure out how to recognize that something is a perfect square so we can factor to here. This is going to be really important because we're going to start to look into trinomials that don't have a 1 as their leading coefficient. So one of the first things we're going to check for is it a perfect square? Now what you're checking for, because this one is, if we remember back to when we had special products, one of our special products was a plus b squared. And in what we just had, that was like x plus 4 squared. You have your a and your b. If you were to square a sum like this, you end up with a squared. And remember the really important part, that 2ab, we have to remember in the middle, plus b squared. And we also had the possibility of squaring a difference. You would have a squared minus 2ab, and it would still be plus b squared, because a negative times a negative becomes your positive there. So when we have a trinomial, we're going to be given something in one of these two forms, if it's a perfect square. We have to try to figure out if that trinomial is a squared plus 2ab plus b squared, if it's in that form. So what you have to do is, well, you have to take your first term, and you have to say, is this a perfect square? So, can you take the square root of x squared? Well, you can. This is a perfect square. It would be x. Then you look to your last term here. Is this a perfect square? Well, can you take the square root of 16? Yes, it is 4. So if this is a perfect square trinomial, and spoiler, we know it is, but let's say we didn't, you would have your a, and you'd have your b here. B is 4, a is x. If it's a perfect square, both of those need to be perfect squares, but the middle needs to be 2ab. So if a is x and b is 4, then 2ab equals, well, 2a is 2x times 4 is 8x, which is your middle here. So then you would know it factors to a, in this case, plus b squared. And this is going to be something we look for. We call these perfect square trinomials. Now on the second slide here in the presentation, it goes through both of these kind of scenarios, how it works out, and it goes through the description of what you should be asking. And I want to talk about the example that they have in there. The example they have is going to be where we start to see a is not equal to 1. A is something that's different than 1. It looks like this. And again, the first thing you're going to ask, so this is going to be a new pattern we look for. Notice we have a trinomial, there's no GCF. So the first thing we're going to say is, well, a is not equal to 1, so as of now we don't really know how to factor that, so we're going to look for, is it a perfect square? And what you would do for a perfect square is this a perfect square? 16x squared, that is 16x squared, and you can think of taking the square root. They kind of have it listed as what squared equals that, and that's 4x squared. So you'd square 4x to equal this. So that's your a is 4x. So your a term is 4x. And then you would say, is your c over here, your plus c, is that a perfect square? and, well, plus 9. 9 is a perfect square, so you have a 3 over there. And then you met the first two criteria. Now your middle term has to be 2 times the product of those two. So 2 times the product of 4x times 3. Well, 2 times 4x is 8, times 3 is 24x. So this is a perfect square, so this would be a perfect square trinomial. So you're checking these two terms to see if they're perfect squares, and then checking to see if the middle is 2 times the product of those square roots of those two terms. We'll go through a couple of examples, and then we'll mix it in with what we've done in the past. So our next example, we have 4y squared plus 12y plus 9. Now if we're going through the steps of factoring GCF, there is no GCF, so we can't use a GCF. There's more than 2 terms and we're adding, so it can't be a difference of squares. We would normally go to factoring a trinomial because we know how to factor when a is 1, but a is not 1, so our next step is going to say, well, is this a perfect square? So right here, 4y squared, you can take the square root of 4y squared. Square root of 4 is 2. Square root of y squared is y, so it's 2y. You can take the square root of 9, that equals 3. So both of these are perfect squares, but we have to make sure that middle is equal to 2 times the product of these two. So 2 times 3 times 2y. 2 times 3 is 6, 6 times 2 is 12y. So the product times 2 of these is equal to 12y. So that means this is a perfect square. And we're going to go back to these terms up here, the square roots. If it is a perfect square, it's going to be a binomial squared. And our a term here is 2y. Our b term is 3. Since we're adding that middle, we're going to be adding here. So your factored would be 2y plus 3, that binomial, all squared. That would be the factored form. All right, on to our next one. We have 9x squared minus 24x plus 16. So again, no GCF, clearly not a difference of squares. It is a trinomial, but we only know how to factor when we have a leading coefficient of 1 so far, so we need to check to see if it's a perfect square. And to check to see if it's a perfect square, can we take the square root of 9x squared? Well, the square root of 9 is 3, square root of x squared is x. Remember, this works with square roots. Take the square root of each factor there. So it's 3x, so this is a perfect square. And the square root of 16, well, that's nice. We already know that should be 4. So we're good so far. And now let's check 2 times the product of those square roots. So 2 times the product of 4 times 3x. Well, 4 times 3x, that's 12x, times 2 is 24x. We're close. It should be a minus 24x. So all that means is that we should have had a minus here. It means we are a perfect square, but instead of adding the b term, we're going to be subtracting. It's still going to be a binomial squared. So it's going to be 3x minus 4, that binomial squared. When you have a perfect square trinomial, you can have a plus or a minus for your middle term, but your leading coefficient and your constant term here, well, it doesn't technically have to be a constant term, but your c term is going to be positive, because when you square this, that negative 4 would become a positive 16. So to be a perfect square, you should have a plus sign here. If you had a minus, then it wouldn't be a perfect square, because when you square it, it would have to be positive. All right, so our next slide on here goes through just these steps. Nice little chart, and we've been talking about these as we've been doing factoring. But the first step you should always go through, first step should always be look for a GCF, and then you kind of have some choices to make. Our next step, I like to say if there's 2 terms, then check for a difference of square. So if you have 2 terms, you're doing a difference of square. And if you have 3 terms, well, then you're kind of leaning back on the coefficients. If it's a leading coefficient of 1, then you can factor like we know how to. If it's not a leading coefficient of 1, so if you have 3 terms, if you have a leading coefficient of 1, factor like normal. If not, then I would check to see if it's a perfect square. Check if perfect square. And if it's not a perfect square, well then that's what we're going to talk about in the future, how to factor if it's not a perfect square. So I have 4 more on the last slide here. I'll go through all 4 of them. Some of these might not be perfect squares. We're going to kind of combine in some of the past topics that we've done. So let's look at our first one. We're trying to factor here. We have 25 x squared plus 60x plus 36. And we want to go ahead and factor this. So GCF, I do not think there is a GCF with any of these. And it looks like it's not a difference in squares. Leading coefficient isn't 1, so we have a trinomial. We're going to check to see if it's a perfect square. Can you take the square root of 25x squared? Well, the square root of 25 is 5, square root of x squared is x, so this is a perfect square, this term. And our last term, 36, that is a perfect square. If you do 2 times the product of these two, that would be 2 times 6 times 5x. So that would be 60x, which is our middle term. This is a perfect square. So it's going to be a binomial squared. You're going to take your a, which is 5x, your b, which is 6. You're adding here, so you're going to have 5x plus 6, that whole binomial squared. And just like that, we factored. Tomorrow we'll really talk about how we can use this when solving an equation. On our second term, 2x squared minus 24x minus 90. So first step, try to find a GCF. And here we actually do have a GCF. We can factor out a 2. So x squared minus, now it becomes 12x minus 45. So we factored out a GCF. But now we have to check to see, can we factor this trinomial any further? So kind of ignore the 2. Can we factor that any further? Well, how would we factor that? There's 3 terms, so not difference in squares. We already took a GCF out. It's a trinomial, leading coefficient of 1. So we should hopefully be able to factor. If not, it would be prime. Let's see if we can factor. Looking for factors of 45, notice the minus sign. So if we can factor, it's going to be 1's plus, 1's minus. So we have 2 factors that multiply to be negative 45 and add up to be negative 12. So if you're listing factors of 45, b was negative 12, c equals negative 45. You can go through some, try some. I happen to know that we're going to have 15 times 3 is 45, and we need to figure out which one would be negative in order to add up to negative 12, and that would be a negative 15. So 15 times negative 3 would add up to negative 12, meaning it's minus 15 and plus 3. And now we have completely factored right down here. So this one wasn't a perfect square. We still can fall back on past methods that we know. All right, on to our next one. Our next one, we have 8x squared plus 48x plus 72. First step, always look for that GCF. And GCF here, well, I know these two definitely have an 8 in common, and this has an 8 in common as well. So factor an 8 out of here. So 8 squared, 8 goes into 48 6 times, so 6x. 8 goes into 72 9 times. So there we go. Now we're left with this right here. And you can factor this either as a leading coefficient of 1. If you wanted to check to see if it's a perfect square, you could. The reason why it jumps out to me as it might be is I know 9 is a perfect square. I know x squared is a perfect square. And it's kind of easy to do really quick. Square root of x squared would be x. Square root of 9 would be 3. And then if you do 3 times 2, that's your 2ab, because your a is 1. So it would be 6. So this would be x plus 3 squared. If you didn't recognize that and you did it the old-fashioned way that we know, it would just be x times x, and you would say what times what is 9, that equals 6, and you would come up with 3 and 3. And then you could just rewrite it as x plus 3 squared. So it's always okay if you have that leading coefficient of 1 to fall back on that. You'll still come up with a perfect square if it is a perfect square. Alright, so we're done. We have 8 times the quantity, x plus 3 squared. Alright, on to our last one of the day. We have 16x squared minus 56x plus 49. So GCF, I don't see a GCF that we can pull out. And what's nice about GCF is sometimes it does like kind of uncover that something is a perfect square after you take the GCF out, which we just saw in the last one. So that sometimes is really nice. But no GCF here. Difference of squares, clearly not. We have three terms in our trinomial. We have a leading coefficient that's not equal to 1. Let's check to see if it's a perfect square. So can we take the square root of 16x squared? Yes, that would be 4x. If you square 4x, you get 16x squared. And 49, we can take the square root of that. That would be 7. Of course, we're taking the principal square roots here. So let's see. 4 times 7, or 4x times 7, that would be 28x, but you're multiplying by 2 to get that middle term, which is 56x, but we have a minus sign here. How that minus sign changes things is you take your a, you take your b, and you're going to be subtracting instead of adding in the binomial, which will still end up having the positive at the end, positive in the beginning. You'll just have a negative middle term. So here's our factored version, 4x minus 7, that quantity squared. Okay, so now we have a new method to go along with GCF, our trinomials with leading coefficient of 1, difference of squares. Now we can check for a perfect square trinomial if we have a leading coefficient that's not 1. And in the future, we'll talk about how to factor if the leading coefficient is not 1 and it's not a perfect square trinomial. Alright guys, have a nice day.